2-1 relations and functions. This lesson is all about relations and functions, and specifically functions. How to tell what a function is, how to tell different types of functions, and all that good stuff. Anyway, relation. Relation is this a collection of ordered pairs. So it could be anything. So most times we know this as numbers like 2 and 3. I put a little parentheses there. But it could also be like symbols. Triangle and box. That's actually a square. Box would be 3-dimensional, but whatever. It could be stuff like here. It could be January and 32. The whole idea is it has to relate one thing to another thing. That's it. That's what makes a relation. It could be colors, blue and green. As long as you're relating one thing to another thing, it's a relation. Now the domain of the relation is just the x values of the relation. So here's my ordered pair, right? We generally consider it's like an x and a y. And all the x values are the domain. So my domain here, it uses a little curly bracket, the collection. So 2, triangle, January, and blue. That'll be my domain. I like to little put x there, so I know it's the x values. Then the curly bracket just means it's like a list. So you're saying, hey, the domain are these items here. Where like parentheses say it's a relation, or it's like this number to that number type of thing. And then if I want to range is the y value. So it's a collection of the y values. So my curly brackets, all the y values of the range. So 3 square. I almost said box again. I was a bit mad at myself. 32 green. And there you go. All right, so those are all the domain values. Those are all the range values. And that's a relation. Now let's talk about what makes a function. So a function and relation, I don't know why it's double. It's a relation in which every x value in the domain corresponds to exactly one value in the range. Essentially that means is all the x values are different. So all x values are unique or different. So if you have a relation, you want to know if it's a function or not, all you have to do is check all the x values. If they're all different, it's a function. I don't care at all about the y's right now. If I want a function, all we care about is that all the x values are different. So I go back to my relation up here. Right, my x values are 2, triangle, January, and blue. They're all different. This is a function. Alright, so let me do a quick example. Let's look at these. So here's a relation, right? Even though it's not numbers, just saying, hey, this triangle goes to that reddish orb. That yellow rectangle goes to that yellow thing. So it's a relation still. If you look at these, are all different. That goes to that, that goes to that. This is a function. These are all unique. And then here's an example saying it's not a function, right? 1 goes to A, 2 goes to D, 3 goes to B, and 3 goes to C. So this right here is why it's not a function. Because 3 gets used twice. So not a function. So again, anytime one of your x values is used more than once, it's not a function. Like if I list this out, this would be 1a, it would have been 2d, 3b, and 3c. And right there you're like, oh, I have 2 3s. Little cheater. So not a function. Now it's a little easier to check, right? Just list it like this. So look at all the x values. There's 2 4s. Not a function. Still a relation, just not a function. And over here, if you notice all the y's are the same, I don't care. I just care about the x values. Only that matters. And they're all different, so this is a function. And that's how you tell if I give you like a set of ordered pairs, or we call a mapping function thing here, mapping relation, if it's a function or not. Next, what if I give you a graph? So if you want to tell something is a function based on a graph, we do what's called a vertical line test. So the general idea is this. You draw a vertical line. If you have the graph only one time, then you pass. So it's a function. If that line you draw, you can draw it anywhere. If it's a graph more than once, it fails. And it's not a function. If you want to know why, look at this point right here. That point was It's kind of hard to see now, but it was like 1, 1, and 1. Oops, I think it's 1, 2 actually. So that point's like 1, 2. This point down here is like 2, negative 2. 1, negative 2. I could count. If you notice, you have 2 of the same x's again. So that's why it's not a function, right? So if you draw a vertical line, you hit it more than once, that means you have the same x, so it's not a function. So let's quickly do some examples. Yeah, I know these are written on my thing, but not on yours. Anyways, we're just going to draw some vertical lines. Feel free to pause anytime you want. Right, so those are supposed to be straight, sorry. It's not the easiest thing to do. Hey, look at each one I hit it once, no matter where I draw, you want to hit it once, so this is a function. This one right here, though, that's supposed to be a straight line. You hit it twice, you know it's not a straight line exactly. This is not a function. I can spell function, hopefully. Over here, a lot of people get confused on this one. They're not sure, is that a function or not? Well, that's what happens. If you draw a line as straight as possible, unlike me, you hit it all up and down this line right here. You have a vertical line, it's going to hit it way more than once. So it's really not a function. Right, like over here it's fine, over there it's fine, but right here, it's not a function right there. So not a function. And that's how you tell by graphing. Now that we know what a function is, let's talk about some special types of functions. 2 in particular. So first one's called a one-to-one function. And this is exactly what it sounds like. So the definition is each element of the domain pairs to exactly one element of the range. All this means is, kind of like the domain, in this case, both the x and y values are unique. So nowhere do we have 2 of the same, right? So 1 goes to D, 2 goes to B, 3 goes to C, right? They're all, there's no doubles at anywhere. So if you have both the x, y values unique, we call that one-to-one because each x value goes to exactly one y value. And they're all in the different y values. So that's, right here, this is a one-to-one function. This right here is an example of what's not a one-to-one function. It's a function, right? Look at all the x values, they're all different, so it passes the function test. But right here, that c is going 3 and 4. So it's not a one-to-one function because there's 2 c's here. There's 3c, and then there's 4c. So this one's not one-to-one. C's a little two-timer. If I give you a graph, how do you tell if it's a one-to-one function? Well, you can do what's called a horizontal line test. So if something passes both a vertical line test and horizontal line test, then it's a one-to-one function. So like right here, you draw a line. You only hit it once. Exact same rule as a vertical line test, right? You only hit it once. And then it's a one-to-one function. So if it passes a vertical line test, it has to be a function, plus the horizontal line test, then it's a one-to-one function. Now this one right here, this does pass a vertical line test, so it is a function, but if you draw this, it doesn't pass the horizontal line test. You cross it twice, and just like before, that means you have 2 of the same. In this case, 2 of the same y's. So it's not one-to-one. Again, still a function, it's not a one-to-one function. So that's a one-to-one function, right? All the x's and all the y's are different. So on the function, you only care about the x's, and a one-to-one function, you care about both. Now we have an onto function. Onto just means all the y values get to use. So all the range gets used. Y values, right? So if you have a function where all the y values gets used, we call that onto function. I mean, it's onto all the range or something. So look at here, this is a function, right? They're all different. And then over here, it's not one-to-one because c gets used twice, but it's all being used, so it's called onto. Right, so very easy to tell if it's onto if I give you like a mapping function. You just look, hey, is all the y values going to use? Yes. Over here, no, right? That c has nobody to play with. It's all alone. So this one's not onto. It is a function. It's actually one-to-one. It's actually a one-to-one function. But it's not onto because that c has no friends. Right, very easy to tell on a mapping function. That's an onto function. That's not. And look at this one right here. It's a function, it's one-to-one, and it's onto. So this is a one-to-one onto function. When you put it all together, you get a one-to-one onto function. Look how pretty it looks. Now, actually, based on a graph, we're actually not going to do that based on onto. I won't ever ask you based on onto. They have to tell you the ranges first. It gets complicated. So don't worry about that. Let's do some examples. So same idea. I just want to know if this is a function, yes or no. If it is a function, is it onto or one-to-one? So look at this first one. Remember, first thing you check all the domain values. These are all different, so it is a function. And then look at the y values. It's not one-to-one because of this guy right here, right? Look at that, hanging out both b and c. I see you, but it is onto, right? All this gets used, so it is an onto function. It's an onto function, not one-to-one because of q. Look at b. A gets used twice. There's AQ and AR. So right, anytime you see the x values get used more than once, it's not a function. AQ and AR, x values used twice. So this is not a function. So look at this one. This one gets a lot of people confused. So you have A go to P, and you got C go to Q, and you got D go to Q. But you're not using B. That doesn't matter. I don't care about that. Who cares? Right? So A, C, and D, they're all being used separately, so it is a function. Now it's not one-to-one because Q gets used again. I see you, Q. Again's playing both C and D together. And R is not getting used, so it's not onto. So it's just a regular old function. Not one-to-one or onto. And then one right here, the final one. I guess the final one of this set. A goes to P, B goes to Q, C goes to R. So it is a function again. It's all nice. They're all different. It is one-to-one, right? No one gets used twice here, so it is one-to-one. But it's not onto because that S right there is not getting used, so poor S. So it's a one-to-one function. Now I can give it to you in different ways. I could give it to you in a graph like this, right? Easy way to check if it's a function. Again, you can still do the vertical line test, and right here it would not pass. So that's one way to do it. Or you could just list them out and do it that way. If you do that, you could probably see a little clearer. See how one gets used twice? So this is not a function. Over here, all your x's are different, so it is a function. It's a u, not a con. If you notice, there's two of the same y, so it's not one-to-one. And this is one you can't tell really if it's onto or not. It looks onto, but you have no idea what the range is. So let's say function for now. Again, I will only ask you onto functions with the mapping set. Otherwise, I'll tell you what the range is. That's it for like one-to-one onto functions. So let's move on to this Dwayne Wade question. So here's our first application problem. So first, let's see. Assume the ages of the domain. So they want this to be his age to be domain there, right there. And define the domain of the range. So domain is, if I was doing this A, they want the age to be domain. So domain would be 24, 25, 26, and 27. The range was 2 points per game. Notice I did it 6 because I'm listing stuff out, so I always do the curly brackets when I do a list. 27.2, 27.4, 24.6, and 30.2. So done. Write a relation of these order pairs. Oh, I don't want to do this. B, so they want to put in order pairs like 24 and 27.2, right? The little relation. That lets you know, hey, when it's 24, you average that many points. And I'll do 25 and 27.4 and I'll stop there because I am lazy. So you get that. Done. Say whether the relation is discrete or continuous. Actually, we're not going to talk about that. We'll talk about that. The book hasn't gone over yet. We'll talk about that in, I think, chapter 10? The book assumes you know it already. Okay, so D, graph the relation is relation function. So we could, actually I don't need to graph it. I know it's a function. All the x's are different, right? The domain doesn't double, so it's a function. But we'll graph it to make them happy. I'm going to do a crappy graph, 24 and 27, like that. And then 25 is a little bit higher. Even less than that. I don't know why I did that. 26 had a down year. And then 27, he came back with a vengeance. So let's connect the dots. I get that. So again, yes, it's a function. Passes the vertical line test. So there that goes. Let's move on. Okay, this part. So here they want you to graph the equation and then tell if it's a one-to-one function onto all that good stuff. So again, I won't ask about discrete and continuous, so we're going to talk about that in a later chapter. And I'm only going to give you onto because they don't give you the range, so I'm only going to give you onto if it's a mapping function. So it's literally just graph it to tell if it's a function, if it's one-to-one or neither. Now the way we graph this, we actually haven't learned yet. If you know how to graph this using different methods, great. As of right now in the book, we haven't learned any other method besides this. Just do what your calculator does and plug in points. So I'm gonna plug in like -2, -1, 0, 1, 2. Now I'll do this fairly fast. That's 2, 8, 6, and then 1, so I get -6, and then plug in 2, I get -10. Right. All I did was plug those numbers in. So I plugged in -2 in for x. Probably should have showed this earlier, and I got 8 minus 2, which is 6, and the same for the rest. Again, in this book, I haven't actually learned how to graph otherwise yet, so I'm gonna do this for now. If you know another way, that's great. Just gonna do this for now. Again, I'm terrible at drawing lines. So there I go. Not the right graph. It should be a little lower, but whatever. I'm gonna go with it. And I want to know if it's a function, if it's one-to-one. It is a function. Passes the vertical line test. And it also passes the horizontal line test. Alright, so it's a one-to-one function. Y equals 3x squared. Again, we haven't learned how to graph this yet, but the default always, I'm going to say this all year, default always is make a chart. So I'll plug in like -1, 0, 1, because I'm lazy. Plug in -1, you square negative, you do, actually let's go all the way to 2. You do this first, I get 1, 1 times 3 is 3. Plug in 0, I get 0. Plug in 1, I get 3. Plug in 2 is to show. Again, do this first. Remember, x1's go first. So 4 times 3 is 12. If I graph it, it looks something like this. Ooh, that's ugly. So it looks something like that. It does pass the vertical line test, so it's a function. BOT passed. But it does not pass the horizontal line test. Fail. So it's just a function, not a horizontal, not a one-to-one function. X equals 7. So I'm gonna do the same thing. So this is interesting. So I actually can't plug any numbers for x because no matter what I do, I'm gonna get 7. So no matter what my y is, I can plug anything. I'm just plugging numbers for y, I should say, right? Plug in 0 for y. There's nowhere to plug it in, so I get 7. Plug in 13 for y. There's nowhere to plug it in. I just get 7. So no matter what I put here, I get 7. So all they're saying is x is always going to be 7. So the way that works like this. You go where 7 is on your x, and just follow the tally mark. That's the graph. Now if I do a vertical line test, it is not going to pass. Oh, this is not going to be nice. Like we talked about before, it hits it the whole way down. So this is really not a function. Did not pass a vertical line test. Hit it all the way down. So that's what this little lesson is about. So okay, graph it. Again, we haven't learned any fancy graphs yet, so all I did was plug points in. That always works. It's always a default. If you're not sure what a graph looks like, just plug in points. That's what your calculator does. Okay, last thing here with functions. Let's talk about how to evaluate functions. This is one of the most important ideas in all mathematics. So here we go with f of x equals -4x plus 8. Really what you want to see this as is this. It's f of space equals -4 times space minus 8. What I mean by that is whatever's in here, you plug in right there. Right, so over here they have f of x and they have -4x. I could plug in, I could say, hey, what's f of triangle? And all you can do is go -4 triangle minus 8. I could say, what's f of 0? And plug 0 in for the space. And so on. So that's all it is. I don't care what I put there. All you do is plug in for the x right there. That's how a function works. So in this case, I want f of -3. So f of -3. Plug in -3 for the x, the space where x is holding. And I get negative 4 times negative 3 is 12. 12 minus 8 is 4. And that's your answer, 4. Right? So I could write like this if I want to. My answer is just 4. It's like a sentence saying, hey, when you plug in negative 3, you got 4. So that's my answer. Don't go and divide by negative. Don't do anything else. 4 is your answer. So with that in mind, let's do this. Oh, I guess I got another one. I'm sorry, I lied. Let's do this one here. I want g of 5. So they want to know what happens when I plug in 5. So just plug it in. So again, I'm going to do this first. So I get 25. Then I'm going to multiply by here. So I get negative 50. This is 20. So minus 20. Plus 1, I get negative 70. Plus 1, I get negative 69. So again, you could write like this. When you plug in 5, you get negative 69. But really your answer is just that. That's how you evaluate a function. Just plug the number in. Now actually, let me go back to those graphs I didn't use. I like this. That's how you evaluate a function if I give you an equation. Let's talk about how you evaluate a function. Let's go all the way back over here. Oh, let me erase some of this. It's fancy tricks. There we go. Let's talk about how you evaluate a function if I give you a graph, which is far more interesting. If I want to figure out what f of 2 is. So again, what this is this is your x value, your domain, and I want to know what the y value is. So all you got to do is go to 2 in your x. Right here, and then where's the graph at? 1. F of 2 is 1. Let me do another one. What's f of 0? Well, go to 0 my x. Here's my x. Go to 0. Here's my x. Go to 0. And your graph hits at, like, let's say negative 3. If I want f of 4, again, go to 4 on your x. Follow the graph. Also 3. That's why it's not negative 3. That's why it's not a horizontal line test. It's not a one-to-one function. Let's do it one more time right here. Let's figure out what f of 1 is real quick. That'll be the last thing I do. So again, on your x, go to 1, and then follow the graph. Where does it hit at? It's at also 1. There we go.